Good day, everyone. We are working on this question number 10 from January 2021, CSEC Mathematics, paper 2. And this is a matrices question. We have a matrix W, and we are told there's a 2 by 2 matrix L, capital L, such that W plus L will give 0, 0, 0, 0. So let's set up our matrix equation. So we have matrix W here, 3, 6, negative 2, 5. We are adding a matrix L. Let's call these entries A, B, C, D. And that will give 0, 0, 0, 0. All right, so let's add row 1, column 1, the corresponding entry A. That will give 0. 6 plus B, which is row 1, column 2, will also give 0. Negative 2 plus C will give 0. And 5 plus D will also give 0. So when we solve these equations, A will be equal to negative 3, B will be equal to negative 6, C will be equal to positive 2, D will be equal to negative 5. The resulting matrix capital L would be negative 3, negative 6, positive 2, negative 5. That's our answer. There's a 2 by 2 matrix P such that WP is equal to the identity matrix. So therefore, W times W inverse is equal to the identity matrix. Okay, so we know matrix W is 3, 6, negative 2, 5. All right, W is equal to 3, 6, negative 2, and 5. So we want to find the inverse of W. So W inverse is equal to 1 over determinant by the adjoint. Okay, so the determinant of W is equal to 3 times 5, take away negative 2 times 6. Okay, so that'll be 15, take away negative 12. 15 plus 12, since a minus is a plus, we get 27. All right, so this can also be written like this. All right, determinant of W and the adjoint now. And we just switch around these entries. The 3 and the 5 switch around, and the other entries, we change the signs of the other entries. So this will be our adjoint. So W inverse, which is equal to P, is equal to 1 over determinant, 1 over 27, multiplied by the adjoint, 5, negative 6, 2, and 3. And this would result in 5 over 27, negative 6 over 27, 2 over 27, and positive 3 over 27, because we multiply each entry by 1 over 27. We could also simplify this. We can reduce the lowest terms, 5 over 27, negative 2 over 9, 2 over 27, 1 over 9. Okay, and that is our matrix capital P, right, which is also the inverse of W. Okay, let's move on. We have a right angle triangle with certain vertices. We are given the points, and we are given a transformation matrix N. We are asked to find the image M prime. Okay, the coordinates of the vertices of M prime. So what we do is we take each point and multiply it by this matrix 0, 1, 1, 0. So row by column. All right, we have a 1 by 2 matrix multiplied by a 2 by 2 matrix. So that will give us a 1 by 2 matrix as our answer. So 1 times 0 is 0, plus 1 times 1 is 1. And 1 times 1 is 1, plus 1 times 0 is 0. So we get 1, 1 as our value for x prime. Right, x prime is 1, 1. Then we take 3, 1, which is y, and we multiply by the same matrix, 0, 1, 1, 0. All right, matrix capital N. So row by column, 3 times 0 is 0, plus 1 times 1 is 1. And then we have 1 times 1 is 1. Sorry, we have 3 times 1 is 3, plus 1 times 0 is 0. So we get y prime being 1, 3. And then we have 3, 4. So let's just remove these commas here. All right, so 1, 1, we have 3, 1, we have 3, 4, right? So we have them in matrix form. That's why we remove the commas. All right, we're multiplying by the same transformation matrix, capital N. So we have 3 times 0 is 0, plus 4 times 1 is 4. We have 3 times 1 is 3, plus 4 times 0 is 0. We end up with 4, 3. Okay, as our image of the point Z. Okay, the point Z. So Z prime would be 4, 3. So as we can see, the X coordinate and the Y coordinate have been interchanged with each other. All right. So this is a reflection on the line Y is equal to X. Move on, we have vectors now. We are given some information and we are given a diagram. Write in terms of U and V an expression for LM. So we are asked to find an expression for a vector going from L to M. Okay, as indicated in red on the diagram. Write in terms of U and V an expression for LM. So LM is equal to LP. So we can go from L to P and then from P to M plus PM. We know that LP is equal to common U and we don't know PM. So we want to find out PM. All right. Now, PM happens to be 1/2 of PQ. Since M is the midpoint of PQ, that vector, right, which is equal to 1/2 times, and we have PQ being PO plus OQ. All right, so going from P to O, right, the magnitude is from O to P is 3U, 2U plus U. So in the opposite direction, it will be negative 3U plus positive V. All right, so that is P. All right, so this is PM here, 1/2 of negative 3U plus V. So let's just work out LM now. LM is equal to U plus PM being, right, 1/2 negative 3U plus V. You can simplify this by removing the brackets. 1/2 times V is 1/2 V. And then we have minus 3 over 2U. So 1U minus 3 over 2U would be negative 1/2 U plus 1/2 V. Okay, that's the answer for LM. We can also simplify it by taking out the 1/2 and having V minus U. Okay, and this will be LM. All right, so we are now asked to find PR. All right, so PR, let's just draw another line. from P to R, and this is a vector PR, and PR is equal to PO plus OR. So we know from Q to R is another vector V, since Q is the midpoint of OR. So OQ would be equal to QR, which is V. So to get PR, we can say PO plus OR, or we could say PQ plus QR. All right, so if we say PQ plus QR, what we get is, all right, so we have PQ, right, PQ being V minus 3U, okay, as seen in the brackets here, we worked it out before. So V minus 3U plus QR, which is V. So this will give us 2V minus 3U, all right, this is the value of PR. Prove that the points LM and R are collinear. So if we can prove, we are trying to prove that LM and MR are parallel. And if they are parallel and they share a common point, that implies that they are collinear, meaning they all lie on the same straight line. So let's just draw a line here. All right, so what we are trying to prove is that we are trying to prove that L, M, and R all lie on the same straight line. Okay, these are the, all right, so this point, and this point line on the same straight line. Okay, so we have LM being 1/2 by V minus U. This is our answer here for number 1. Let's get MR now. MR is equal to MQ plus QR. Okay, M to Q, Q to R. So MR is equal to MQ. Let's make that a better. MQ plus QR. Okay, so MQ is the same as PM. So PM is equal to 1/2 times negative 3U plus V. So 1/2 times negative 3U plus V. Remember MQ is equal to PM. Okay, so therefore we are working out MR here. All right, so MR is equal to MQ plus V. All right, so QR is equal to V. So when we remove the brackets, 1/2 times negative 3 over 2U plus plus V. Sorry, 1/2 V plus V. Okay, so we have negative 3 over 2U plus 1/2 V. 1 plus 1/2 is 3 over 2V, or 1/2 V. So what we have here, when we look at, okay, what we have here is we have 3 times negative 1/2 U plus 1/2 V if we factor out the 3. Okay, and that can be written as 3 times 1/2 V minus 1/2 U, which is 3 times 1/2 times V minus U. Okay, now 1/2 times V minus U is LM. So, right, and this is MR. So therefore MR would be equal to 3 times LM. right? And since MR is a scalar multiple of LM, then, okay, not then. And M is a common point, right? This proves that points the points are L, M, and R. L, M, and R are collinear. Okay, so MR is a scalar multiple of LM. All right. And that means they're parallel. All right, but they both share a common point, meaning they are parallel and connected to each other. All right. This proves that points L, M, and R are collinear. Okay. So we did prove that they were parallel, but they have a common point. Therefore, they are collinear, meaning they all lie on the same straight line. Thanks for watching. We are finished with this test paper. Have a great day.